Hi, this is our third video from section F4, and most of the problems deal with these type of situations. Find the center and the radius and graph this. And we're going to graph the circle. And I'm giving you three different problems, and they kind of go in a hierarchy of difficulty. This one's got some threes in front of the x squared, y squared, so I decided to make sure I do one of those for you. But there's an extra problem that I want to do as well, and I didn't have enough room on the board this first time. So when I get these three done, I'm going to erase number 22 over there and put another problem on it. It's going to be 40, problem number 40 that's in the book. And but right now I'm going to find the center and the radius. I want to graph the circle. And actually there's other things that they want us to do, and that's to find the intercepts. So we're going to do that. Now, first problem is x squared plus y minus 1 squared equals 1. So what I can do is find the center. Remember, it's always in the form of standard form. Is x minus h squared plus y minus k squared equals the radius squared. So the center in this case is going to be at 0 because there is no h. Remember, h is default 0 if it's not there. And k is 1. And remember, it's not negative 1 because it's the opposite of it, or you can think of it as what makes this one 0. And the radius is the square root of this 1 right here. And so in this case, the radius is 1. So the center is at 0, 1. The radius is 1. And I can graph that. So 0, 1 right there, and the radius is 1. So count 1 unit up and count 1 unit down, and try to draw the best circle that I can actually do. So that's about as best it gets for me. So the center is at the 0, 1, and the radius is 1. Now, in this particular case, the intercepts are fairly easy because you can kind of see it on the graph. But you can't always go by that. I mean, it looks like the center should be, the intercepts should be, an x-intercept is at the origin, and a y-intercepts are going to be at 0, 2, and 0, 0. Again, the origin. So that's what it appears what the intercept should be. But you're like, well, how do you find intercepts in general? Is to set x equal to 0 to find the y-intercept, and set y equal to 0 to find the x-intercept. So let's do it that way just to confirm what our suspicions here. So to find the x-intercept, we set y equal to 0. So x squared plus 0 minus 1 squared equals 1. And so x squared plus 0 minus 1 squared is 1 equals 1. So x squared equals 0. So let's subtract the 1 to the other side. And then take square root. So the x-intercept is at x equals 0. Now the y-intercept, you remember that one, you have to set x equal to 0. So 0 plus y minus 1 squared equals 1. And then I could FOIL y minus 1 squared out. But I also could take the square root of it right now, and that's what I'm going to do. So y minus 1 equals the square root of the other side, which is plus or minus the square root of 1, which is 1. And if I add 1 to the other side, I get 1 plus or minus 1. But what's 1 plus 1? Now it's 2. That's where it crosses the 2. That's on the y-axis. And what's 1 minus 1? That's 0. And that's why it crosses back at the origin again. So just like the graph indicates, the intercepts are at 0, 0 and 0, 2. So, and they're not all that easy. Sometimes they kind of hit in between two numbers, and you can't just tell by looking at the graph. And you really have to play this game right here, setting y equal to 0 to find the x-intercept. And set, this one maybe not so much, but in some cases you would have to do that. Okay, so this one here is in general form. Okay, I have to put it in this form right here. this is what I was talking about in that first video, finding the center and the radius in general form. You have to backtrack and put it in that standard form by completing the square. So you got to know how to complete the square on this one. So how you do that is this: x squared, and we're going to collect terms together. I'm going to collect the x squared with the 6x, the y squared with the 2y, and I'm going to move that 9 to the other side. So it's kind of like, you know, putting family members together, you know, so it's like, you ever been to a family reunion, all the same families usually go to one table and somebody else goes to another table that's on the other family. So they usually intermingle. Well, that's what we're doing here, is we're putting all the individual families together. So we're putting these x's here, putting these y's here, and putting the numbers here. So now, so how do you complete the square? Well, we have to make sure this is a 1, and it is, which in circles you're not going to have that problem. Then you take half of the number in front of the first term. So this one's the first term. So half of -6 is -3. Half of -6 is -3. And when you square -3, you get 9. So why do you do that? Why do you put a +9 there? Because that's going to make it a perfect square. And making it a perfect square puts it in this form. Now, before I tell you what I'm going to have to do with it on the other side, what I'm going to show you first is to show you that this actually does work. This is the reason you do it. X times x is x squared. -3 times -3 is a -6x. And then -3 times -3 is a +9. So it's going to be x minus 3 quantity squared. So that's kind of the reason I wanted to do that. But remember, I put a +9 there. It wasn't there to begin with. So to keep an equation balanced, you've got to put 9 on the other side too. Now the equation becomes balanced again. Now you do the same thing with the y's. So y squared plus 2y, there is a leading coefficient 1, so we're good there. Half of 2 on front of the y is 1. And then square that number, and that's 1. If you don't pick the right number here, you'll know, because it won't factor. And if it does factor, it won't be a perfect square factor. So now y squared plus 2y plus 1 factors to y plus 1 times y plus 1. And that becomes y plus 1 squared. But I put a 1 there, just like I put a 9 there. When I put that 9 there, I had to balance it off by putting the 9 to this side. So I put a 1 here, so I got to put a 1 over here. So the right side just knocks down to 1, because the 9's cancel. And so that's 1. So now you're no worse off than you were on 22. So the center is at 3, -1. Now remember now, how to find the center is set these equal to 0. What makes that one 0? That's going to be 3. And -1 makes this one. And the r is the square root of that number, which is 1. So let's look at the circle by the graph. So 3, -1 right there. And the radius is only 1, so it looks like this. Okay. Now, if you look at this, guys, it doesn't look like it's going to have a y-intercept because the radius is only 1. So if it's at 3, -1, and the radius only being 1, it doesn't go far enough to hit the y-axis. But if you don't think about these things, you're just very mechanical, and you just kind of do what the routine that you're used to. You'll go through the routine, and you'll try to solve it. And then about 5 minutes later, you determine, there is a problem with the y-intercepts because it doesn't give me real answers. So what I'm talking about. So let's say I do this, and I say, okay, I want to find the y-intercept first. So what I'll do is I'll go back to my beginning equation and to find the y-intercept. You remember how to do that? You got to set x equals 0, right? So 0, so that's y squared minus plus 2y plus 9 equals 0, because all the x's in the equation is 0. So then try to solve that. Well, it doesn't factor. Well, that's okay. It may not. But then if it doesn't factor, then you got to find you got to use the quadratic formula to find the answers. So y equals the opposite of b, -2 plus or minus the square root of b squared, that's 4, minus 4 times 1, because the a is 1, and the c is 9. You really don't need to go any further than this, because look inside the radical. It's 4 minus 4 times 1 times 9. And if you do the math on that, that's a -32. But you can't take the square root of a -32 and get a real number. Because remember, number lines are real axes. They're just real number lines. Square root of a -32 doesn't exist on this number line, or this number line either. So square root of -32 does exist. So after about, here, what are we, 2 or 3 minutes later, we found out that this one's unsolvable. But at the very beginning, if you would use your noggin a little bit, you would have said, okay, it doesn't stretch over far enough to hit the y-axis, so there won't be a y-intercept. So it's little tricks that you'll learn. And then over here, you look at this one, so the radius is 1, so it looks like it's crossing the x-axis at 3, 0. And you're like, well, is that what it is? Well, if you look at the original equation and find the x-intercept, then set the y equals 0, so that one's 0, that one's 0. So you get x squared minus 6x plus 9 equals 0. And if you factor, it's x minus 3 times x minus 3 equals 0. So x is indeed 3. So that is the x-intercept. So, but again, that's one of those things that it appears to be at 3, 0. Okay? So that's 28. And now finally 34 here, it looks a little tougher than 28 just simply because there's 3's in front of it. Well, if you divide everything by 3, and you can, then it becomes easier than 28. Because this becomes x squared plus y squared minus 4y equal to 0. So, and then what you would do here is, well, that's already a perfect square. There is no x term on this one, but there is a minus 4y. So what we'll do is y squared minus 4y, half of -4, and square it. That's 4. And then you got to add the 4 to the other side as well. So this 4 was added here to make this a perfect square. But to balance the equation out, you have to put plus 4 over here as well. So it becomes x squared plus y minus 2 times y minus 2 equals 4. And so x squared plus y minus 2 squared equals 4. So the center is at 0, 2. And the radius is 2 because it's the square root of 4. So now if you graph that, you got center at 0, 2. The radius is at 2. And if you look at this very closely, it looks like a problem kind of like that one over there, number 22. So it looks very similar, except this time the radius is 2. So you can still pick out the origin and the point. This time it's 0, 4 as your y-intercepts. 0, 0 is the x-intercept as well. But if you're not comfortable with that, what you'll have to do is go back up and put x in for 0 to solve for the y, to find the y-intercept, and vice versa on the other one. So, and I'm going to let you. I want you to verify that for me. To verify what the intercepts are. But it appears the intercepts are going to be at 0, 0 and 0, 4. So, and as I promised, I want to do one more problem here, number 40. So I'm going to have to erase number 22 here. Maybe part of 28 as well. Sometimes you need a little bit bigger boards than you have. But make do with what you have. So, all right, now on 40, what do they want me to do here? All right. The problem says in the book, we want to find the standard form of the equation of the circle, and that's all, just standard form. But what do we have? We have the endpoints of the diameter They better be giving me 2 points, and I think they do. It's 4, 3, and 0, 1. Now, they just tell me what the endpoints are, the diameter. So it looks like this. 1, 2, 3, 4, up 3. And then the other one is 0, 1. So 4, 3, and 0, 1. And this is the diameter of the circle. And I'm not a very good artist, so you're going to have to forgive me a little bit. But this is what's going on. So 0, 1, and 4, 3 are the endpoints of the diameter. So we're having to come up with the equation of the circle. X minus h squared plus y minus k squared equals r squared. And we've done a problem like this a while ago. Okay? But this one is set in here, number 40. It's a little different because a while ago when we did the diameter was parallel. And so it's very easy to find the distance between the two ends. So here you've got to actually use the distance formula to find the distance between the ends. So, but what is the midpoint? The midpoint is still the center. So the center is the midpoint. So it's going to be, it's the average of the x-coordinates, so 0 plus 4 divided by 2, and 1 plus 3 divided by 2. So the center is at 2, 2. And I'm not the best artist in the world, but it does kind of look close to 2, 2. Here's 2 to the right and 2 to the up. It's a little above 2 just because I don't draw very well. So the center is at 2, 2. So x minus 2 squared plus y minus 2 squared equals the r squared. Now I just have to find the radius. Again, you have a choice. You can find the distance between the center 2, 2 to the point 4, 3, and then put that number into the formula, or you can find the distance between 0, 1, and 4, 3. Okay, and then half it because the radius is half the diameter. I'm just going to go ahead and find the distance between 2, 2 and 4, 3. So just find that distance right there. So r is equals to the square root of 4 minus 2 squared plus 3 minus 2 squared. So r is equals to 4 minus 2 is 2 squared is 4, I believe. And then 3 minus 2 is 1, and square, and that's 1. So r is the square root of 5. Well, you don't put square root of 5 there because that's what the radius is, square root of 5. The equation is set equal to r squared. So you don't care what r is in particular, you care what r squared is. So if that's the square root of 5, that means r squared must be 5 because you can square both sides, r squared equals 5. And then you just replace the r squared there with the 5, and then you're done. So that's number 40. So when dealing with circles, the two important things is the center and the radius. That's the important thing. Just like when you're dealing with lines, the important things, one of the important things was the slope and another point. Sometimes that point was a y-intercept and sometimes it wasn't. But to find the equation of a line, you had to know something about the slope and kind of a point where it's kind of located on the Cartesian plane. Well, here you got to know two things as well. You got to know where the center is at, and you got to know what the radius is at. You're dealing with a different formula than you dealt with back in F3. So, but it's the same idea. You know, it's the same things. You got to have certain information in order to do it. Just like if you don't know the point slope formula, if you don't know this one, you're kind of dead in the water right off the bat. So these equations are non-negotiable. Being close doesn't count. If you put everything right and except you don't put your squares there, that's a common mistake, by the way. People forgetting the squares on the terms. Another one is putting an x plus 2 and a y plus 2 there. So getting the signs wrong inside there is a common mistake. And I've seen this mistake once or twice in my 20-some odd years of teaching, putting a minus in between there. So And I'm not sure where they're getting that one at, but I've seen that there too, but not very often. So, but anyway, this is our third video. We have one more to go in F4. So thank you for watching.